a sphere of the radius r, where we have a total charge on it. So we have r is given and total charge is given. Is uniformly distributed through the volume of the sphere. So it's uniformly distributed. Let's say it's positive charge. This is a positive charge plus q everywhere. Okay. What is the magnitude of the electric field at a point halfway between center of the sphere and its surface? So we have to find electric field at the half distance of r. Okay, let's call it small r. So that means our r is equal to r divided by 2, halfway between them. So you take the Gaussian surface around this one, and you have to find the electric field at point here. Okay, so how can we find it? First of all, we know that the charge volume density, the rho, is equal to the total charge divided by the total volume, and this is also equal to the charge in the halfway of the capital R or small r divided by the volume of the r. Okay, so that means total charge is given, volume is 3/4 pi r cube is equal q. Now small volume of this one is basically 3/4 pi r cube. Now since we know that r is a half of the capital R, which means q divided by 3/4 pi, now the r/2 cubed. Okay, so from there, as you can see, this will cancel out, then r cube will also cancel out. At the end, we can see that the total q divided by 8 gives small q. Okay, what else? Now we know that the area of this sphere, especially this shaded sphere, will be what? Area is equal to the 4 pi r squared. Correct? We also know that flux is equal electric field times area, or q enclosed divided by epsilon naught. So from here we have to find the electric field, which is q over epsilon naught area. Now the area is obviously equal to the 4 pi r squared, and since we know that small r is equal to the half of the capital R, which is q over epsilon naught 4 pi r over 2 squared. Okay, from there what we have, q divided, so this becomes 4, so we end up with epsilon naught pi r squared. Okay, then finally we know that small q is equal capital Q over 8, so you plug it there, capital Q 8 epsilon naught pi r squared. So that's it. This is your final formula.